Hi friends, in this video we'll have a look at variables in C. This is very simple as usual, but first we'll understand the story and the reason behind the things so that we'll understand variables much better. I can do this variables in less than 2 minutes 30 seconds or 40 seconds, less than a minute. Okay, before going to that, let's understand what is a memory. Okay, we have heard the word memory multiple times, using mostly through pen drives. Nowadays, everybody carries one as their thing. Hard disk, CD, DVD drive. These are different memory devices, and the next set comes RAM and the processor. Okay, so all these things serves a different purpose. Okay, the first set is called secondary memory or the tertiary memory, whatever way you want to put it down. Like it's not the primary memory. Okay. So all these guys, like in the first list, can hold lot of data. So it can hold lot of data permanently as well. Okay. Let's assume I'm copying a movie to a pen drive. It will be there till I delete it or until unless the pen drive is corrupt by a virus. Okay. The same goes with the hard drive as well. Whereas CD or DVD till I break it. Okay. So it can store to GBs to TBs as well. For a purpose of a demonstration, I put it 500 GB. It can hold up to TBs. Nowadays, it's becoming cheap. Okay, 2 TB hard disk, 5 TB hard disks are pretty cheap and efficient as well. Then comes the RAM, which is called as the main memory. Okay, if somebody asks which is the main memory, always remember RAM is the main memory. The reason for its existence is the speed. Okay, the processor is like a horse. Okay, it is way beyond the speed of hard disk or a pen drive. So to give an analogy, if the processor is like a horse, the secondary memory is like a tortoise. Okay, that is the speed difference between these two guys, or an elephant. Okay, so if we want to match the data speed between these two guys, somebody has to be there who is a temporary store. So who feeds continuously to the process speed. Okay, so that thing is solved by the main memory. He holds all the data for certain period of time, okay, till the machine restarts or whatever it expires, and he supplies all the data or all the information to the processor. Okay, so at a time multiple processes can exist in main memory. The main memory can range up to 256 to 8 GB, 16 GB. Now 32, 64 GB is very normal for us. Okay, so the maximum number of usage is dependent on the OS you are using it. If it is a 32-bit OS, its addressable limit is different. If it is 64-bit OS, the addressable limit is little different. Okay, so that is the main memory thing. So main memory thing is a bridge. That's essentially what it is. Okay, the bridge will help you to connect between these two guys, but it will not store the data permanently. Okay, so then comes the processor. Processor is like the fastest thing. It does all the computations, and it is always hungry for information and data. Okay, so in human analogy, it could be the brain, but not exactly the brain, because our brain is much more efficient and smarter than what the processor is. Because for us, our memory and the processing unit are in one. Okay, whereas in terms of computers, it's like two different things. Like it's a hard disk and versus processor, but for us, it is one and the same. Okay, so that's why still the AI things, artificial intelligence things, are not able to match the human speed. Okay, once these guys are speed and fast enough to match each other, then what the AI will pick up. Okay, going back, the Terminator will come in pitching. Okay, now going back to the story. Okay, so the main memory is limited. Yes, the size is very limited. It's not like a secondary memory. It is much fast. So not fast as processor, but way fast than a hard disk. Okay, and shared memory. The main memory is not exclusive for one person. It is shared between multiple processors. So for example, when you are watching this, currently we are running a PowerPoint presentation, which is the one which is showing it, and I am running a recorder program which is recording it, and parallelly there is some other background processing which could be happening at the back, and there is a Word file which is running at the back as well for me. which is store running, having some data. Okay. So it is shared and it is volatile. Volatile means like when the power goes off, the entire contents get vanished. Okay, that is the drawback of main memory. Okay, so and for I said multiple processor sharing, right? So every processor has a limitation, because if one processor takes the entire chunk of main memory, the others will not get the speed. So what they do is like the OS puts the limitation for the processors. So you can access only 2 GB of the main memory. Let's assume if you have 8 GB, at max you can go for 2 GB. That's the thing. Okay. So now going to the variables. So now only the actual story starts. Before that is a background thing. So I'll tell why it is needed. So whatever your C program runs will have two parts. One is a code segment, another one is a data segment. Code segments will have the code which you have written, 5 lines of code or whatever it is. The data segment will have the data which is related with it. The data could be a global data, it could be a local data. Okay, but in the essence, all the data is stored in the data segment. To understand a little bit further, you have to understand few more things like a stack and a heap, which we'll cover in the different tutorial altogether. Okay, so coming to the variables. So variables are a simple thing. It's a placeholder which will hold a value. For example, int is the data type, a is the placeholder, and 10 is the value. Like that, the other two variables were there. So now let's go back to our basic second standard addition. Okay, we'll keep like 2 plus 3 is equal to 5. This is the thing. So we used to have when we started first standard or LKG, we used to have our fingers count like 1, 2, 3 in this right hand and 2 in the left hand. Okay, first is we remembered using the fingers. Then we went with our brain for holding things. The same way, the programs remember all your data using the variables. Okay, the variables are the placeholders. Okay, it remembers what you want to do with that. So once the program executes, that's it. It forgets everything. If it is closed, it forgets the things. Okay, so that is the analogy which we can give it. Like, so if we want to do the same addition in a code, what we have to do is we have to declare 3 variables. Okay, a equal to 3, b equal to 2, or a equal to 2, b equal to 3, and sum equal to a plus b. Like that we have to give it. Okay, so that's the way the variables are helping us to solve the problem. It holds the data and it helps you to progress further, and it helps you to remember. And there are 2 parts to remember. Like, there is always a limitation how much you can remember as a human. Okay, at a point of time. Okay, the same limitation is there for the computers as well. Why it is there? Because OS says that you can only access 2 GB. Okay, so that limitation is imposed by the OS, and because of that thing, this guy is also like trying to make the limitation as much based on his instructions. Okay, and the second thing is like how long we can remember. Okay, let's assume I'm remembering something. So I have a very volatile memory. Like I forget things within maximum its lifetime is 10 minutes. Okay, whatever I do. No, I mean, I tried a lot to keep it better, but it didn't happen right now till date. Okay, so these are the 2 things which we have a trouble. The same trouble is also there for computer. Computer is also a thing which is created by us, right? So we put our limitations into the computers as well to a certain extent. Okay, so now mapping these 2 guys, like things we remember. And whereas the machine, it's called size. Okay, every variable is restricted by its size. Okay, and how long we can remember is the next question. That is called scope and lifetime, which we'll cover it in the separate video, which will discuss how long you can remember something, or how long you can see a variable. Okay, so those are the 2 elements. When we can map this thing to our human thing. So going back to the type, first point. Okay, why we need type? Okay, type helps us to specify the size of the things. Okay, here the different types are int, float, char. These are the different types. Char, double, long, whatever types is. There are a lot of types, but I have listed only 4 types. So every type will have a size limitation. So it can store only a certain size of the value. Beyond that, if you try to store it, either you will be losing your value or you will be getting a junk value. One of the things could happen. Okay, so you are supposed to carry 2%, and if you are trying to carry 3%, you will break. Okay, the same thing happens for the type as well, which is which ultimately points to the size. Okay, the next thing is like a range. Okay, we'll have a look at that a little later. Okay, now going back to the variables. The variables has 3 things. One is the name, another one is the value, the third thing is the address. Okay, address says how to get it and where to get it. So as we said, like in memory, we are storing the data. So memory, how to go and take the memory. So address is the one which points to certain memory, and to know the address, use a operator called AND operator or ampersand operator. Okay, ampersand, AMP or SAND, ampersand operator or AND operator it's called. Let's if we declare a variable like a equal to 10, okay, what happens is like the int is the data type and a is the name of the variable, okay, and 10 is the value which is holding it. Okay, the address is not visible for you, okay, because it is not human readable or rememberable, so they have masked internally that one. So most probably the address would be a number, which is a pretty lengthy number, hard to remember. If it is a phone number, we would have remembered like based on something, but in program already we hate things, so beyond that, like we don't want to remember all those numbers. Instead of that, we can at least better understand the names. Okay, so a equal to 10 means what it happens is it goes to the place like 10,015, that is the address location, and stores the value 10. Okay, this is how it happens internally. Though for you it's just a storage of data, internally it maps that data to an address which will hold the data for certain amount of time. The amount of time is determined by the scope and the lifetime, and what data it can hold is determined by the type of the data, which is int, char or whatever it is, long, float, all those things it can hold. Okay, so now moving on with the code. Okay, here let's do a small program. Okay, int a equal to 10. First let's print the address. As I said, if you want to know the address, you have to use the ampersand operator. I am just using ampersand a, which means that print the address. Then print the value in that variable, which is just if I give a, it will store the variable. And if I want to know the size of the variable when I say int, so there is an operator called size of operator which helps me to do it. Okay, let's open the code, the same piece of code over here. Okay, nothing different from there, from the PPT. So let's increase the font size and then try to see it. So the same code, first is the address, second one is the value, and third is the size. Okay, let's compile it and check the value. So going back to the command prompt, mingw prompt. Okay, I'm using, let's clear it. So the font is a little small, please forgive me. It's a little lazy to change it. So I'm typing gcc hyphen file name hyphen o and then file name.c, which is where is my file name, var.c hyphen var.exe. I'm just giving it. So now I've got the value. The code is compiled. So I'm going to run var.exe. When I run it, I'm getting 3 things. First is the address. The address is the bigger number, which is 32,000 something, sorry, 22,093,300 something, and value is 10, and the size is 4 bytes. When I say 4, it's 4 bytes, bytes, bytes. Okay, so this is about the data types and the value and the variables thing. So what you can try is like you can try out with the different variable values and check it out, like declare where different variables with different things. Coming back to the range thing, so there is something called range. So as I was said, like everybody can hold only a certain size of a data, right? For instance, like int is a data type. If I declare int equal to 10, right? If I try to store a value beyond that range, which is 32,767, let's assume I'm storing 32,768, it will give me a wrong value, because it will say that I will not be able to hold the data which you are given the thing. So I am giving a wrong value. That's how the output would be. Okay. So that for that reason you have to understand. So what is the program you are going to write and what is the data size I have to give it. Like if it is a average or average, we'll say. So I will be using better float. Okay. So the average could be 39.5, something like that. So pointer I cannot store it in an int or a int or a char. So what I'll do is I'll use a float. Okay. So like that, whatever number I want to use it, I'll check the range. I mean, I've given only few data types. So your workout is to go and check for other data types as well and learn it. And these are the workouts. So as I said, try to print all the data types with the size and address and understand the things. And next step is like what happens if you store beyond the range. As I was mentioning that example, what if I store like 60,769, how it is a thing. And last but not least, there is something called pointer, which you may not understand right now, but at least hear the word, and if there is a way, like go and just Google it and check it out what pointers means. We'll have a detailed look in the later sections. This is one of the important topics in C, pointers. Okay. Thank you, friends. Bye bye.